In this lesson, you will learn how to use the quadratic formula. Let's take a look at what the quadratic formula is. The quadratic formula looks like this. It says x equals negative b plus or minus the square root b squared minus 4ac, all divided by 2a. We use this formula when we're solving quadratic equations, and our answers are the x-intercepts of the parabola of the graph of the quadratic equation. So we may get two answers, we may get one answer, and we may get no solution, which simply means the parabola has no x-intercepts. So let's take a look at how this works. First thing you have to be able to do before using the quadratic formula is to be able to plug in the values of the quadratic formula. You need to be able to put a quadratic equation in standard form and then identify the a, the b, and the c in the equation. So if you look up here, you'll see standard form, ax squared plus bx plus c. So the number in front of x squared is the a that you will plug into the formula. The number in front of the x is the b, and the constant, or the number without the variable, is our c. So that's how you identify the a, the b, and the c. So let's take a look at two quick examples and simply identify the a, the b, and the c. So in our first quadratic equation, 2x squared minus 7x plus 3, or excuse me, minus 3. If I go ahead and write the standard form of a quadratic equation below it, you can see that the a corresponds to the 2 because that's in front of the x squared. So our a is 2. We do not include the variables, only the numbers. Our b corresponds to the negative 7, and our c corresponds to the negative 3. So again, those would be the three numbers you would plug into the quadratic formula. Now let's take a look at another one. So here we have ax squared, so 4x squared, plus bx plus c. Now you could probably see that something is missing in this quadratic equation because there's only two terms rather than three as we had in the first. So again, you need to make sure and understand that the a is found in front of the x squared, so that would be the 4. The b is found in front of the x, and notice there is no x. So what we could do is we could rewrite this equation. So it does have three terms. We could write it as 4x squared plus 0x plus 5 to better see what our a, b, and c is. So now you can see that the b corresponds to 0, and then the c, which is our constant, corresponds to the 5. So those would be the three numbers we would plug into the quadratic formula to be able to simplify it and solve. Okay, let's look at a quadratic equation. Now if you look at this quadratic equation, you may or may not have learned that you could factor this possibly using a different method called the double bubble method. If you haven't learned this, go ahead and fast forward and just look at what I'm going to be doing on the right. But if you have learned this, I want you to see the difference between the two, yet the fact that they give the same answers. So for those of you who've learned how to factor a trinomial with a leading coefficient of 1, you simply figure out what numbers multiply to 7. So you want to write down your options, and there's only two options. And then you're going to choose the ones that add up to the middle term, which is negative 8. So it would be negative 1 and negative 7. So that's factoring. Now we're going to solve it to find the x-intercepts. So we're going to set each binomial equal to 0. So the first one and then the second. Whoops, should be x minus 7. And then we're going to solve both equations for x. So our first x-intercept is 1, and we can write that as 1, 0 because it's an actual point on the graph. And then our second x-intercept is positive 7, and again we can write that as a point or an ordered pair, and it would be 7, 0. Okay, so that's one way to find the x-intercepts. A second way would be to use the quadratic formula. Now, although the quadratic formula is larger, or takes a little bit longer usually, the quadratic formula can be used for any quadratic equation. So whether you're using a quadratic equation that requires double bubble, bottoms up, or any other kind of factoring, or it cannot use factoring to solve, then you would have to use the quadratic formula. So the quadratic formula is nice because it can be used for any problem. So let's just move that around. So we're going to keep that in front of us. So the first thing we need to do is identify the A, the B, and the C. So A is 1, B is -8, and C is +7. Once you identify those, you can plug them into the formula. So if you look up at the formula above, we're going to have x equals, we're going to drop down the negative sign in front of the b, and then we're going to bring our b, which is -8, next to the negative sign. So negative b, so -8, plus or minus the square root of b squared, so -8 squared. Always put your negative numbers that you're squaring in parentheses, minus 4, which is part of the formula, times a, or 1, times c, which is 7, all divided by 2a. So 2 times 1. Now we need to simplify this. Now what I do when I'm simplifying this is I break it up into parts. So I simplify this and this first, and then under the radical, I do separately. So the -8 is +8. Then I just put a little radical sign here. Then over to the side, I do my math for what's under the radical. So I start with the -8 squared, which is 64. Now be careful when you're multiplying these three numbers because you've got a -4, a +1, and a 7. You have to multiply all three of those together. And when you do, you get a -28. So then you take 64 minus 28, which is 36. So I'm going to put that under the radical. So that's what I get when I simplify. Now there are different options as to what you might get under the radical. In this case, we got a perfect square. And I'm going to do one example of each type of situation that you will see as you use the quadratic formula. So in this one, we've got a perfect square. So we're going to go ahead and take the square root of 36 and make that 6. Now, from here, because I have no more radical, I can finish simplifying this. The plus or minus symbol means I'm going to do two things. First, I'm going to use the plus sign. I'm going to do 8 plus 6 divided by 2, which is 14 divided by 2, or 7. I'm going to write that as a point. And notice that matches the one over to the left from our previous way we solved this. And then, secondly, I'm going to use the minus sign. So I'll do 8 minus 6 divided by 2, which is 2 over 2, or 1. And I'll write that as a point. And notice those two answers are the exact same as the two I got over here. So a different way of doing it, but gets you the same results. The quadratic formula is used a lot because most of the quadratic equations will not have rational answers. So you're going to need to use the quadratic formula, so it's good to get used to using it. Okay, let's look at what happens when we get our answer, actually. Okay, so here we have the same equation we just factored from the previous slide. And here were our two answers, 7, 0, and 1, 0. And I just wanted you to see real quickly what you do with those answers, or how you actually apply that. Now, I went ahead and wrote down the vertex, which is going to be when you have a parabola, if you don't recall or haven't learned this yet. It's basically the minimum point if your parabola is opened up, because that's what the graph looks like of a quadratic. Or if your parabola is opened down, it'll be your maximum point. Okay, so I'm going to graph this point first, 4, -9. That's way over here to the right and down. And then I'm going to graph the x-intercepts, so 7, 0, and 1, 0, which are right on the x-axis, which is why they're called x-intercepts. If I were to draw a line right through where the vertex is, this is called the axis of symmetry. And that should basically cut the parabola in half. So in other words, the two x-intercepts should be equal distance from where the vertex is. And if they are, then you can be pretty confident in your work. Now I'm just going to sketch the parabola like this. So again, what you're finding when you're using the quadratic formula is simply the x-intercepts. And sometimes there will be two, Sometimes there may only be one, and you might have a parabola that looks like this. You get one x-intercept and you graph it, and it may open up or down, but this is what a one answer problem looks like. Sometimes you'll get no solution. The graph exists, it just means it may never touch the x-axis, so it has no x-intercepts. It just has a vertex and other points, but no x-intercepts. So if you get no solution, it doesn't mean that there's no graph. It just means that there's no x-intercepts for the graph. Okay, so let's take a look at the next problem. All right, so again, first thing we need to use the quadratic formula is we need to identify A, B, and C. So our A is 1, our B is 5, and our C is -3. And we're going to plug it into the formula. So we have x equals -b, so go over to b, and that's 5, plus or minus b squared, so these two numbers should always match right here. So 5 squared minus 4, which is in the formula, times the a times the c, all divided by 2 times the a. Now, this we don't have to simplify any further. 2 times 1 is 2. So where we're at is -5 plus or minus a radical divided by 2. Now we want to go under the radical and simplify it in two parts, starting with 5 squared. And 5 squared is 25. Then we multiply the three numbers together, which are -4, 1, and -3. We get a positive 12. And if you add those together, we get 37. Now, in the last problem, we had 36, and we had a perfect square, so we could actually take the square root, which removed the radical sign. In this problem, 37 is not a perfect square, which means that your answer will have a radical sign. So the only time your answer will not have a radical sign in it is when it's a perfect square. Now, in this case, if we could do a factor tree for 37 and simplify it further, we would. But notice when we do it, the only factors of 37 are 1 and 37, so it cannot be simplified any further. This means in order to get your two x-intercepts or your two answers, you would really need to use a calculator, and your answers are going to be irrational answers. They will be decimal amounts that you would have to round, and then you'd graph decimal amounts on the actual coordinate plane for your x-intercepts. But there are two answers. This is equivalent to saying -5 plus radical 37 divided by 2, and then -5 minus radical 37. So if radical 37 was approximately 6.1, then you could actually do the math and kind of estimate your answers. Okay, let's look at this scenario. So each scenario will be a little bit different because there's quite a few, and I want you to see all the different situations. Okay, so for this problem, our A is 1, our B is 6, and the C is 9. So let's go ahead and plug in those numbers. We have x equals -b, which is 6, plus or minus b squared minus 4 times a times c divided by 2a. Okay, so we've got x equals -6 plus or minus some radical over 2. Now let's do the math of what's under the radical. So 6 squared is 36. -4 times 1 times 9 is -36. And that comes out to 0, which is what goes under our radical. Now 0 is a perfect square because remember, a perfect square means what times itself equals the number under the radical. So the square root of 0 is 0. So that means we can remove the radical. Once we do that, we can get two answers, one using our plus sign and one using our minus sign. So -6 plus 0 and -6 minus 0. But what you'll notice in this problem is when you do the math, they're both going to come out to -3. Okay, so sometimes when you get the same answer, that means there's really only one x-intercept, so there's really only one answer. And I showed you on a previous slide, I'm going to go back for a moment to the graph. I'm going to circle it in blue. When you have a parabola that only touches the x-axis once, that means it only has one x-intercept or one solution. So the problem we just did would be an example of that, where it only has one solution because it's only touching the x-axis at one place. So you only write the answer once. Okay, so that's an example of one solution. Let's look at the next scenario. Okay, here we go. Okay, in this problem, we have an A of 3, a B of 13, and a C of 4. So let's go ahead and plug that in. So we have negative B, so negative 13, plus or minus B squared, 13 squared, minus 4 times 3 times 4, divided by 2 times 3. So we have negative 13 plus or minus some square root over 6 this time. So notice the denominator is not 2 because we actually have a value of A that's not 1. Okay, now if we go under the radical, 13 squared, or 13 times 13 is 169. Then we're going to multiply negative 4 times 3 times 4, which is going to be negative 48. And then if we do the math on that, we're going to get 121. And notice that's a perfect square, so that means the radical will be able to be removed, and you'll be able to actually have two x-intercepts. So we've got negative 13 plus or minus 11, which is the square root of 121, divided by 6. So we're going to have negative 13 plus 11 divided by 6, and then negative 13 minus 11 divided by 6. So let's see what that looks like. So well, negative 13 plus 11 is negative 2/6, and that reduces to negative 1/3. So one of our x-intercepts is simply a fraction that you'd have to graph on the x-axis. The other one would be negative 24 divided by 6, which is negative 4, and that would be your other x-intercept. So these are your two x-intercepts that you would graph if you were to graph the parabola for this equation. Okay, let's look at the next situation. Okay, notice this particular quadratic equation, it's not in standard form. So remember, to be in standard form, we need all three terms to be on the left side of the equal sign. So what we want to do is we want to move these two over, but when you move them over to the left, you must change their signs because you're moving them. So the 7x, when you move it over, will become negative 7x, and the negative 6 will become a positive 6. And then from there, you'll just do what you did in the other problems. First, identify your A, your B, and your C. So A is 3, B is negative 7, and C is 6. So let's go ahead and plug those in. So negative B, so negative negative 7, plus or minus B squared minus 4 times A times C divided by 2A. So be careful of all the negatives with the negative 7s. So don't do this too fast, otherwise it's easy to make an error. Okay, so we're going to go ahead and calculate, let's see, the negative 7 is a positive 7. We'll put our radical, and then in the denominator we have 6 again, just like the last problem. Now, negative 7 squared, negative 7 times negative 7 is positive 49. Negative 4 times 3 times 6 is negative 72. So what's going to happen? What's 49 minus 72? Well, let's do 72 minus 49, which would be 23, but it's going to be negative since 72 is bigger than 49. So let's put that under our radical. Now, hopefully you've learned that if you have a negative number under a radical, that it's no solution, because there is nothing times itself that can ever give you a negative answer. So anytime you end up with a negative number under the radical, you're just going to write no solution. Now again, what that means on the graph doesn't mean that a parabola does not exist for that quadratic equation. It means there's no x-intercept, so it will graph above or below the x-axis and never touch the x-axis itself. Okay? So again, whenever there's a negative number under the radical, you can do no further calculating, even with a calculator, and you simply write that no solution, which means there are no x-intercepts for this graph. Okay, last one. And this is probably the most important one, so don't turn it off now, because this involves the most steps. Okay, the first thing you have to do in this problem is, again, look and see if it's in standard form. It appears to be in standard form, but to be in standard form, the number to the right of the equal sign has to be 0, and it's not. So what we want to do is combine it with the like term on the left side. So it will subtract it from the right and bring it over with the 5. So we will have 2x squared minus 4x plus 1 equals 0. Now we can identify our a, which is 2, our b is negative 4, and our c is positive 1. So let's go ahead and plug those numbers into the quadratic formula. So we have x equals negative 4 plus or minus b squared, so negative 4 squared, minus 4 times a times c divided by 2 times 2, so 2 times a. I'm going to extend this page, make it a little larger. Okay, so we have, once we simplify the negative 4 and then the denominator, we have 4 plus or minus a radical over 4. Then under the radical, negative 4 squared, or negative 4 times negative 4 is 16. Negative 4 times 2 times 1 is negative 8. And 16 minus 1 is 8. Okay, and that went under our radical. Now, the reason why this one requires a little more work is 2 reasons. Number 1, when you have a number under a radical that can be simplified further using a factor tree, you must do that. So look over to the left, and I'm going to go ahead and do a factor tree for 8. So I'm going to get 2 times 4. I'm going to circle my prime numbers. And then for the 4, I'll break that up into 2 and 2. So that gives me 3 2's. So for each pair of the same number I have, I take one to the outside and the other one is gone, because I'm really just doing the square root of 4. Anything left over that's not part of a pair stays under the radical. So the 2 radical 2 is what I'm going to replace the radical 8 with. So I've got x equals 4 plus or minus. Now instead of the radical 8, I'm going to put 2 radical 2. Now, this is something I want to make sure you understand. These two 4's right here, you cannot reduce them and make them 1's. In this type of problem, you can only do any reducing if you have 3 numbers outside the radical. So there has to be 3. And then there's a number that goes into all 3. So if there's only 2, like at this stage, you can't do any reducing. Only if you have 3 numbers. So in other words, only if the radical can be simplified could you ever further reduce this. Okay, so at this point, we're going to divide all of those numbers by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. Don't do the one under the radical because you can only reduce what's outside the radical. Then the denominator, 4 divided by 2 is 2. Now, if the number in front of the radical is 1, it's not necessary to write it. So you could really write your answer as 2 plus or minus radical 2 over 2. And again, these 2's cannot be further simplified because there's not a third number outside the radical to reduce as well. So that would be as far as you could go without a calculator. With the calculator, you would type in 2 plus the square root of 2 over 2. Then you would type in 2 minus the square root of 2 over 2. And you would get some approximations for the x-intercepts. Okay, and that completes the lesson on quadratic formula. Good luck.